Find displacement through vector addition. A person walks 10 meters 30 degrees above the positive x-axis. The person then walks 20 meters 50 degrees below the negative x-axis. What is the person's displacement? Alright, so when we do the component method, we want to draw our vectors coming out of the origin. So my first vector is above the positive x-axis, so I'm going to the right and up. So 30 degrees above that positive x-axis. The one is below the negative x-axis, so I'm going to go left and down 2 degrees below that negative x-axis. Now that I have my diagram, I can use my trig functions in order to break these vectors into components. So we're going to have a of x and a of y, and then b of x and b of y. And for both of these cases, our angles are adjacent to the x component and opposite to the y component. So I'm going to use cosine for x and sine for y. Alright, so you can see here I have used cosine for the x components and sine for the y components. Now you do have to be careful here because the minus signs are not going to come out of your calculator. So you'll see that the first vector, they're both in the first, it's both in the first quadrant, so therefore they're both positive. But for the second vector, they're in the third quadrant where they're going to be both negative, so I added those minus signs in there. Alright, so you can see here I've added my x components together, I've added my y components together. So these are the components of our resultant vector. I'm now going to use Pythagorean's theorem, so the idea that r is equal to rx squared plus ry squared. So I'm going to sub that in. And I don't need to keep the minus signs here because I'm going to square it anyways. And sometimes when you type things in your calculator, if you don't put parentheses around it, it won't actually square the minus sign out front. And then you'll be frustrated because you either get the wrong answer or you'll be in the process of trying to do it and you'll get an imaginary number. Alright, so we're going to get 11.1 meters here. And then to find the angle, we're going to use inverse tangent because what this is actually set up as, and I always draw my x component first, so it's going to be negative. So this is my rx, and then I'm going to draw my ry off of it so that my resultant points down here. So I'm finding this angle theta in here. So opposite is y, adjacent is x. So we're going to do the negative 15.3 meters and the negative 12.9 meters. So that's going to give me about 49.9 degrees. And that is going to be below the negative x-axis.